Okay, now you should see a little red dot that says recording. During our Zoom sessions, if I forget to do that, please remind me. Okay. All right, so let's zoom over to Canvas. Okay, and we go to our course. I try to put everything in modules, but sometimes it doesn't get there, or I forget or something like that. But everything is usually in files and pages. And then modules will pull up the pages and files. So if you don't see it in modules, just zoom down to files. And there are more files than there are modules. So keep that in mind as well. Okay, so let's look at the syllabus. Start with that. All right. There are two main things that students want to know about for typically in most classes is how to contact me and how do I grade. And that's usually what I net out of the syllabus. The full syllabus is online, but it's in modules. It's not under syllabus. There's a Canvas listing for syllabus, but I put it all in modules. Okay, so this is how to get a hold of me. We're going to be in, our lab is going to be in Lilith Hall, room 316 on the 3rd floor, which should be the same lab as you had in 305. Unless you took it on another campus. If you took it here, you're in 305, assuming you took it in the last semester over the summer in the new building. Okay, so the Zoom sessions typically go from noon to 2 o'clock or less. Sometimes I end early to give everyone time to get over to the lab in time. This is how to get a hold of me. Many of you have been sending me messages already from Canvas. Office hours are 11 to 12, as I said before, and it'll be on Zoom. And you just need to let me know so we can set that up. Okay, the prerequisites are typically a follow-on of Chem 305, passing it, the grade is C or better, or an equivalent from another college. And you just need to run the transcript by me and preferably the syllabus of that class, showing that you passed it, and the syllabus, and I'll usually look it over. Some people go from Chem 400 to this class, which is fine. But the bottom line is a Chem 305. A Chem 300 would also work if you came from 300. Okay. This class is two main subjects, organic chemistry and biochemistry. And that's a follow-on from your chapter 4. And I'm going to talk a lot about chapter 4 today from your in your text. Okay. As far as what's required in this class, you'll need the textbook. Now, I would, if you haven't got your textbook yet, you might want to look on Amazon. You can rent it on Amazon and buy it on Amazon, frequently used. I'd recommend buying used if possible, because it'll save you money. The current version is 8th, but versions 4 to 7 work fine. Chemistry doesn't change that much. And the more beat up, the better. The best time to buy a textbook is in the middle of the semester or the following semester. I looked up when I was up in Washington. I was looking up some textbooks for students. I was showing them. You can buy a textbook for like $5 for the upcoming semester. It costs you another $5 to get it shipped. You're into it for $10, and you can sell it probably for more than that. But you got to do it in the middle of the semester, though. If you do it at the beginning of the semester, that's when they get the best money. Okay. as far as the lab goes, you're going to need safety goggles, and you probably, if you're coming from 305, you should already have that. The way we want you to get safety goggles is, let me, the type of safety goggles I want you to buy, if you haven't bought any yet, are UVEX, that's UVEX. And I can't write on this screen. I've got another screen I can write on. Let me go over to the whiteboard here. UVEX Stealth goggles. Don't go to Home Depot and buy chemical splash-proof goggles. Only buy this guy here. They're available on Amazon, I think for $13 or something like that. And if you're not a member of Amazon Prime, as a student, you can get 6 months free. After that, there's a reduced rate. So that is a no compromise deal. You've got to have approved safety goggles for lab. As you progress through chemistry, the chemicals get harsher and harsher. Real chemicals are pretty lame in terms of safety goes. 306 are pretty safe as well, but the higher you go, you start using more and more concentrated acids, stronger and stronger oxidizing agents, etc. So anyway, these goggles you can use in your biological classes as well. They're really good goggles. That's the kind I wear. You'll see me wearing. They're very comfortable also. Now, in the summer, we frequently have issues of goggles fogging, and I carry with me an anti-fog compound. So during lab, this is a wet lab now, not a dry lab. During lab, if you find your goggles are fogging up, just let me know and we can apply this anti-fog. Okay, so any questions about the goggles? Okay, so let's go back to okay. The department would like you to wear long pants, closed foot shoes. What I mean by closed foot shoes meaning that Crocs won't work for two reasons. One, they have holes in them. Also, there's no back to the shoe. Okay, so the best way to do this is take your lab coat and your closed-toed shoes and just throw them in the trunk of your car. You can also store them in your drawer if you'd like, but you've got to wear goggles, closed-toed shoes, and a lab coat or apron. Now for class, you're going to need a calculator. The calculator you use in 305 should be fine, or equivalent class. We're not going to be using the calculator that much in here, but you occasionally will be needing to use it. Okay, so that's what we're going to need requirements class. Now, any of you guys, you're awfully quiet. Any of you guys have any questions?
I had a question about the lab manual. Do you guys have, or do you have a PDF version of it by chance?
Yes, but I want you to purchase. If you purchase it, I'll give you a PDF version.
Oh no, because I failed this class like last semester, and then I still have all my stuff. It's just like, do I have to buy a new one?
No.
Okay. I'll just email you about it. Thank you.
Okay, so that's a really good question. Okay, so if you took this class before and you are repeating it, that means you already have a copy of the lab manual. So if you can prove that to me, I will be glad to give you a PDF of it, okay? So it'll save you from buying another one. Does that make
Yeah,
sense?
thank you. I appreciate it. Yeah.
Yeah, that's not a problem at all. Because you already bought it, you know. I just don't want to give it out in the department. This is totally generated from within the department. And there's a publishing fee that has to go through to go to the bookstore, all this stuff. So we need to make a little bit of money on each one. That's why I want you to buy it. If you buy it, I can also give you a PDF version of it as well. So, okay. And then also, what's missing here is the lab packet. So all of you will need to purchase the lab packet over the student store. Do you guys, who has bought a lab packet already? The reason I'm asking, do they have a supply over there?
I still have to pick mine up from the bookstore, so I'm not sure.
Okay. Because we had a real problem over the summer. Has anyone already purchased their lab manual? Instead of holding up your hand, just speak up.
I bought a lab manual from the bookstore on the main campus.
Yes.
Okay, and they have plenty of supply?
Yeah, and if they don't have it that day, they should have it the next day because they print it daily.
Oh, that's interesting. Did they have a stack when you were there?
Yeah, but you have to ask one of the administration to get it for you. You can't get it yourself.
Oh, so you don't really know how many they have.
No, but last time I went, which was last Wednesday, they had a whole box of them, she told me.
Okay. Okay. If anyone has any problem where they're out of stock, let me know and I can give you like the first lab is lab 1 and it's a dry lab. Like the first 2 labs are dry labs, meaning there are no wet chemicals out. And it's basically a workshop or a monitored worksheet session. Now I'm going to be modifying those slightly as well. Mainly leaving off sections that aren't relevant for this class. But I'll let you know in plenty of time. Okay, well, that's good to know that we have supply. Over the summer, we didn't get supply for 3 weeks of our lab manuals. It was a problem. Now, at the beginning of
Professor,
that,
real quick with the
Yeah.
lab coat,
I'm sorry?
are we able to use like our nursing lab coat or dental? It's long sleeve, but it's not long attire.
That would be fine as long as you wear long pants.
Okay.
And once we get into the cooler weather, it shouldn't be a problem. But as you know, it's supposed to be 100 degrees, I think, on Wednesday, Thursday this week. You know, everyone wears shorts, including me. But during wet labs, I like to have your body covered with a combination of lab coat and long pants if the lab coat isn't very long. But the dental one is fine. Just wear long pants. Also, it doesn't matter
Thank you.
what color. As you look on the front screen on Canvas, you'll see me in my lab coat. So I have a tie-dye one. So you can wear, I had a butcher come in, his was black. And person over the summer, she bought a white one but didn't like it, so she dyed it pink. So I don't care what color it is. She also embroidered all kinds of stuff on it. It was really kind of cool. So your lab coat, the purpose of the lab coat is to protect your clothes and your skin from chemicals. Now the chemicals usually won't hurt you, but sometimes they'll stain. Also, if you're wearing cotton clothing and if you get any acid drips or splashes or something like that, it'll create a hole in the cotton. Cotton and acid don't mix very well at all. Okay, so the person that mentioned their dental lab coat, is that a polyester one or a cotton one? Or do you know?
I think it's polyester. It's what we use in the back of the lab we have to use. Yeah.
Yeah. Because it comes both ways. You can get a lab coat that's 100% cotton, which are the ones they usually dye, and then you can get a mixture of one. And usually it's a polyester 100% or polyester cotton blend. It doesn't matter. Any three of those will work fine. So I'm going to go over this again when we get into lab today or Wednesday. But make sure in the next week or so you pick up your lab packet. And we're not going to have, we also have a holiday coming up for Labor Day. So Monday lab people are going to miss that day, which means it's postponed. If you look at the lab schedule, I'll show you in a minute. I'll show you how that's broken down. Okay. Any more questions about required materials? Okay. All right. I learn by doing lots of practice. And because of that, I end up having lots of practice worksheets for my students. So they're going to be combinations of problems from the textbook and worksheets. And then we have dry labs that are also worksheet-like. So those are the three sources of practice. Now, there's also, I'd recommend highly you get into a study group. There's a ton of research showing that students in study groups achieve at a much higher level than people that work independently. Particularly if chemistry is not your thing, study groups are really good for you. They really help you. You get support from your colleagues and friends. If you're all by yourself, you're all by yourself. Now, one thing we're going to be doing in this class that I'll be elaborating on as the first couple of weeks of class is a class project. All of you individually will be doing a class project. So I want you to be thinking about this. If you go over to Files on Canvas, under Project, you'll see some examples of posters, and I'll be talking about those in detail. So you're going to have a whole semester to do this. It's not like it's due next weekend. Whole semester. I want you to start thinking about it today. Okay. Now at the beginning of class, or the beginning of lab, I'll have two things you have to have done before class starts. I'm going to go over that in lab today and Wednesday. But basically, you're going to have a pre-lab questions you have to fill out, and also a pre-lab write-up. Now, 305, depending on who you have, some of you had this and some of you didn't. But 306 is a more formal class than 305, and you're going to be under the guise of the general department's laboratory write-ups, which are a little more involved, but it's just the way it is. Okay, there are two kinds of labs. There's a wet lab and a dry lab. A wet lab is you will have chemicals out, and I'm going to be very, very strict about safety stuff on that. You'll have goggles you should be wearing, closed-toed shoes, etc. Okay? I'm going to talk about this in lab today and Wednesday as well. Now, sometimes you'll be working with partners and sometimes you'll be working by yourself. Okay, let's see here. I'm going to go over safety big time in lab today. You're going to have a research project, and that's what I was mentioning earlier. One of the things that I have been doing for this is going on like decades now, is having research projects for students. Students rarely get a chance to study something they really are interested in and get points for it. That changes in my class, because now you can actually study something you're truly interested in, whether that's drugs, nutrition, food additives, chemistry of vision, whatever. You have an opportunity to study that, and you're going to be creating a multimedia poster and essay combination, and you'll get to study something you're interested in and get points for it. In fact, you'll get enough points that it equals a test. Okay, study groups. I really, again, I'm gonna keep emphasizing this. Get into a study group. Canvas allows you to send messages to each other, and you can kind of get together on Canvas to kind of put a study session together, talk about putting a study session together. But anyway, I highly encourage you to do that. Okay, so how do are there any questions so far? Okay,
I have a quick question.
Yeah.
So the files part is not on Canvas right now. I don't know if you're gonna open that up later, but it only has modules, grades, and home. I think it's what's on Canvas right now.
oh, okay, tell you what, I'm gonna change that like right now as we're speaking. Let's see, that's right, I agree with that. Okay, so that's showing. Which one? Thanks for telling me that, by the way. Okay, you can see it now.
Yeah.
Okay. Back to how I grade. You're gonna have 700 points total in there. There's a possibility it might change a little bit, depending on how the weather is and all that stuff. But basically, to start with, you're gonna have this many points. And notice here under project, you get 100 points for an excellent one, which is the same as your 3 tests. And final actually too. Your total of all your labs, you're gonna have 12 labs at 15 points apiece. That's 180 points total. The labs are basically, you're gonna have a pre-lab, that's worth 5, and then the lab itself is right up. The finished lab itself is worth 10 points. So 15 points total per lab. In the next week or so, you have 2 assignments that are due. One is called a lab waiver, which is a Los Rios district policy regarding lab waiver. And I'll show you how to do that. And there's a lab safety contract too. Now you're going to be downloading the PDFs, signing them, and uploading them into the assignment. Now, if you've had 305, I'm sure you've already used to uploading stuff to assignments. If not, let me know and I can go over how to do that. Are there any questions about how to do that? When you click on the assignment, it should prompt you for a file. And that's going to be the scanned PDF. You're going to be turning in all your labs that way. So you need to get a scanning a scanning sorry, I'm a block for the word application on your phone. There's a lot of them available and there's a lot of free ones, so make sure you get a free one. And you're going to be creating one file, one PDF file of all the pages you scan. And that one PDF file is the one you're going to be uploading. Okay, and I can show you how to do that when we get closer to the lab. Okay, now this is goofy because it's Canvas is parsing this PDF file strangely. But anyway, basically, if you have a disability, you are in the process of contacting me regarding any accommodations you may have. And this is how we're going to be doing lecture topics. Now, And this all comes out of your textbook. We're going to be reviewing chapter 4, parts of it. The main thing in chapter 4 I want you to focus on are Lewis dot structures and a little bit on valence shell electron repulsion, VESPR. Remember the tetrahedral, trigonoplanar, that kind of stuff in 305. Focus on that. And then chapter 12 is where the organic chemistry starts. And this is the schedule we'll be following. You're going to have 3 midterms, plus a final, plus a project, plus your labs. Okay. Okay. Holidays. Now, this is the lab schedule right now. Are you going to also having, because this is an online class, I don't like giving online tests. What I do is I give the tests in lab, so it'll be person to person. And Monday's test will be different than Wednesday's test, just FYI. Okay, so this is the lab schedule. Now for Labor Day weekend, that Monday, there's going to be no, obviously, lab that day or lecture. So Wednesday's lab, you're going to be picking up dry lab number 2, and then the following Monday, folks are going to pick up lab 2. Wednesday's lab of that week is going to be review before the test. Anyone can come to that lab, not just Wednesday folks. We'd like to review for the test. We're also going to do that here as well. Now, the first test is going to be very indicative of the rest of the tests. In organic chemistry and biochemistry, all the tests sort of look the same, just the content is a little different. In 305, the tests were very different each time. One time you're doing dimensional analysis, another time you're doing stoichiometry, another time you're doing electronic configuration. In this class, the tests will look very similar. All tests will be in 3 parts: naming, intermolecular reactions, or excuse me, intermolecular forces, and chemical reactions. Every test will have those 3 on it. I can give you old tests as an idea of how long they are and how I ask questions. In fact, I'll be posting that. If someone would remind, can someone send me an email to remind me to post a practice test for test 1? And I'll post that in files and modules. Okay, but anyway, this is our schedule. And I noted, except for one problem, I noticed that, where is it? The sunscreen is a dry lab, not a wet lab. I just noticed that. Okay, once we pass test 1, we don't have a holiday till, oh, we don't have any more holidays issues. And I teach at Sierra as well. And there I teach it Friday, Saturday. There's all kinds of holidays that really mess up the schedule. But here, just that one day, the Labor Day weekend, we have the lab mixed up a little bit. Okay, so that's the syllabus. This is always a, in case I messed up, that was available information at the time. Okay, are there any questions about the syllabus? Anything about how things are going?
Hi, Professor.
Yeah.
For the exam, I noticed that one of them, it says that the final could be replaced one of the 3 tests if the final exam is higher.
Yeah, you're asking about if you get a D or F in one of the tests.
Okay.
Yeah, if you get a D or F in one of the tests and you do better than a D or F on your final, I'll swap out that test grade for your final grade. Is that what you were asking?
Yes, but then it has to be a D or F, right? It can't be like a C or something like that.
Normally I do D or Fs,
Okay.
unless there's extenuating circumstances. But in general, if you D or F, I don't want, because if you get an F, it's hard to recover from an F. But if you get a C, you can recover from that. Getting a D or an, and for a lot of the schools, the allied health schools, you're required to get a B in this class. In fact, some of my students repeat this class if they get a B, they want an A in this class. So there's a lot of reasons for you to do well in this class. So that's why if you get a D or F on one of the tests, it's really hard to get a B in the class. So I'd like to give you some way to recover. Does that make sense?
Yes.
Have you taken this class before?
This is my first time.
Okay. You'll find this class very different than most classes in chemistry. Okay, any other questions?
Professor?
Yeah.
If we're Monday labs, do we have an in-person lab today?
I didn't quite hear you. Could you speak up, please? I'm old.
That's okay. I have my AirPods in, so I wasn't sure if it picked it up.
Okay.
If we have the Monday labs, do we have an in-person lab today?
Yes.
Okay.
Now, if there was some confusion on that and you can't come today because you thought it was the first week you didn't have it, it's a dry lab.
Okay, sounds good.
Excuse me, that's next week. This week is just a lab safety introduction, so we can talk about that. I can, if there's a real problem for some reason you can't make lab. Now, if you can't make Monday, you can go to Wednesday lab, by the way. So there's some flexibility there. Does that help?
Okay, yeah, that's okay.
Okay, any questions about the syllabus? Let's see, we have,
Hello, Professor.
Yeah.
I have a question. When should I bring the lab supplies with me? This week or next week?
next week. Good question.
Monday or Wednesday?
Yeah, it doesn't, today's Monday lab, which is gonna be repeated for Wednesday. So this week, class is split in half, Monday or Wednesday labs, lectures, both Monday and Wednesday. So, this week we're gonna talk about the lab write-up. You're gonna watch a video safety movie, which is just real exciting. It's the American Chemical Society video, and all the department has to show it. It's a very informal day today. Next week is going to be much more formal, and that's when we're going to start dry lab number 1.
Okay, thank you.
Okay. Oh, I forgot to start something here.
Hello, Professor.
Yeah.
So we have labs on every Mondays and Wednesdays?
No, Monday or Wednesday.
Okay, so this week we have on today and Wednesday, both days, right?
No, you have lecture Monday and Wednesday. Lab, you have either Monday or Wednesday, depending on what section you signed up for.
Okay, so my schedule shows my lab is on Wednesday, not today.
Correct. So I'll see you on Wednesday at 3 o'clock.
Okay, got you. I was a little bit confused that I have labs on both the days. That's fine. Thank you.
Yeah, well, shouldn't you say your documentation says you have lab both days?
No, it says on Wednesday, but after hearing that lab is today also, I was confused that I read it wrong.
Oh, okay, yeah. Yeah, because we have the Monday people today, Wednesday people on Wednesday. But lecture is for both Monday, Wednesday people.
Okay, got you. Thank you.
Sure.
I have a question about the final.
Yeah.
So it says the finals on Monday. Is that Monday for everybody for both classes?
It's during finals week.
Okay.
And finals week assigns a time based on when lecture is.
I see. Okay.
So what you would do, and what I was required to do, is I look at my lecture slot, Monday, Wednesdays, noon to 2, excuse me, yeah, noon to 2, and then they would tell me when the final is. So everyone will take the final that Monday, the 11th, I believe.
Okay, thank you.
Okay, let's see, let me do one thing here. Okay, anytime now. What? What we're going to do is we are going to, I don't know why it won't let me create I use OneNote a lot. I have a tablet that uses OneNote as well. So what I'm going to do is use a Kim 400 section here. Okay. Okay, so we're studying Kim 306, as I mentioned before, is a combination of organic and biochemistry. Organic chemistry is you look this up you Google this, for example, it'll say the chemistry of carbon, but it isn't just the chemistry of carbon, it's the chemistry of carbon, hydrogen, oxygen, nitrogen, typically sulfur. And we're going to be looking at these a lot this semester. Now, what I do is when we have an organic topic, like for example, if we were studying aldehydes and ketones organically, I would then also study at the same time carbohydrates, because the chemistry of carbohydrates is aldehydes and ketones. When you study carboxylic acids, for example, then we're going to study lipids. When we study amines, then we study proteins. So that's the way we're going to do it in this class. Is we have an organic set, and we have a biochemistry.
Sorry, Professor, are you meaning to be sharing your screen?
Let me do that. I can't believe I can do that.
Also, I was wondering, can you see like the chats that people are sending? Because people are like asking you questions in the chat.
Show chats. I have show chats checked, but there's like 24 there. Let me go through these really fast. I don't know why it's not showing them to me, but I gotta manually look at them. Oh, I didn't mention lab coats. Someone asked, looks like Sayla asked about lab coats for the bookstore. Yes, they're available at the bookstore. However, if you want to get a free one, go to the chemistry stockroom on the 3rd floor and ask for a loaner lab coat, and they will usually give you one that's been donated. And I would recommend taking it home and washing it and doing all that kind of stuff, but it's free. Also, the biology department offers the same thing. And since we have lab on Mondays, the beginning of the semester, beginning of the week, go to either of the stock rooms and ask for a lab coat, and they should be able to give you one. Okay, I'm not guaranteeing how wonderful it is. And then, of course, you need to tell them your size. I usually tell people to get a little extra large than they normally would wear for street clothes, just so it's loose fitting and they're not confining. And let me go through these chats real fast, make sure I answer this question. Lockers are going to be towards a few weeks from now. Yeah, the first week of wet lab is usually typically going to do lab drawer. No multiple choice questions on the test. Okay, regarding supplies for lab, I can't believe I didn't see any of these chats. These are all really good questions. The only lab stuff you need to worry about this week is show up. You don't have to fill out anything. Okay. Next week, you're going to be bringing your dry lab number 1 to be filled out. Yes, you're supposed to be looking at what I'm writing. That's because I haven't shared it. Sorry. Okay. All right. Sorry about that. Okay. Okay. Can you all see this now?
Yes.
Yeah.
Okay. Now, you guys, keep me honest. Like, why am I not responding to chats? We can't see this, okay? So just keep me honest, okay? Because I'm assuming you can see this as I'm writing away. Okay, so Chem 306, it's a study of organic chemistry and biochemistry, as I said before. If you look at organic chemistry, and by definition, it's usually the chemistry of carbons. But it's not just carbon, it's carbon, hydrogen, oxygen, nitrogen, and sulfur, and how they all interact. The way I designed this class, and many of the other instructors that teach 306, what we do is we combine the organic and the biochemistry set together. What I mean by that is, for example, if we're studying aldehydes and ketones in the organic part, then the next topic taught is carbohydrates, because the chemistry of carbohydrates is the chemistry of aldehydes and ketones. If we're looking at organic acids, that would be the chemistry of lipids. If we're studying organic amines, that's the chemistry of protein. Unit 1, Unit 2, Unit 3. As we get into this more, this will make more sense. In the beginning, we look at chapter 12, which is on alkanes and alkenes and alcohols. And then we get into these other things, okay? But basically, that'd be test 1, test 2, test 3. This will make more sense as we get into the lecture one. But that's how most, at least in this department and at fact Sierra and up in the schools I taught at, for what this is typically what most professors do in their allied health organic biochemistry, is they teach the organic part, then they teach the biochem component of that. However, most textbooks don't do that. They jump around. They cover carbohydrates after amines. Then you have to reteach the aldehydes and ketones because everyone's forgotten them by the time you get to carbohydrates. So anyway, that's why we do it this way. That makes sense? Okay, so now I want to start off by, I already told you there's no math in this class. I should say very little math. However, what I want you to review from your 305 class is chapter 4. So chapter 4, the main thing in chapter 4 is Lewis dot structures. I'm going to go over those in a minute. We're going to be using these every single day, Lewis dot structures. Not really complicated ones, fairly straightforward ones, but we will be using them every day. The other thing we're going to be using a lot of are different ways of representing both organic molecules and biochemical molecules. That's really the focus of dry lab number 1. Is this guy here. Okay, also you're going to be studying Lewis dot structures or practicing them in lab 1 as well. Okay, so let's talk about Lewis dot structures. Hopefully this is a review. I'm using OneNote, by the way. Okay, Dr. Lewis. Had a problem. Because about 150-ish, 180 years ago, at that time in chemistry, all they could get were formulas like this. They didn't have an associated structure. So what Dr. Lewis did is he, number 1, said valence electrons determine structure. Now, if you remember from valence electrons, there are 2 kinds of electrons, core electrons and valence electrons. If we're looking at, for example, lithium. Lithium has 3 electrons. 2 core, 1 valence. Now, if you remember in the periodic table, you find lithium and I'm looking for a periodic table here. That I can grab. All right, here's lithium. Lithium again has 3 electrons. What you do to find valence electrons is you go to the row the element is, and you count from left to right, and that'll be the number of valence electrons. So lithium is 1N, so that means it has 1 valence electron. All the rest are core. That means these 2 electrons here are core. This has to add up to 3. Okay. Normally, elements have lots and lots and lots of core electrons and not very many valence. But according to Dr. Lewis, valence determines structure, not core. And there's a thermodynamic reason for that. That's to do with core electrons are extremely stable. And to modify the core organization, you have to put a lot of energy into that reorganization. Okay, so what we're concerned about are number of valence electrons. So, as far as Bohr is concerned, we have 1 valence electron, 2, 3, 4, 5, 6, 7, and 8. Doesn't matter how many core. So, for example, sulfur has the same number of valence electrons as oxygen, 6. Silicon has 4, just like carbon. Different numbers of cores, valence electrons determine structure. So that's what Dr. Lewis was going on. That's what the Lewis dot structures are based on, the valence electron interaction. Okay, so are there any questions about that? Valence versus core? This is out of chapter 4.
I have a question on the core the core, I think electrons, right? Yeah. So that is based on what I think you call a period is, right? So it goes like 1, 2, 3, 4, 5, 6, 7, and lithium is in the second period, I think is how you'd say it. So that determines the core electron. Am I right? Or I'm just trying to remember.
No, that determines valence electrons, the periodicity.
Okay, but like going like down.
Yeah, going down.
How do you
Yep.
determine the core electrons then is what I'm asking.
Core electrons are left over. So for example, if we look at silicon, excuse me, if we look at sulfur, okay? Okay, sulfur's got 6 valence, right? Because it's in period 6. But it has 16 total. So how many are core?
Got it. Okay, that makes sense now.
10 core, yeah. And the 10 core, you just kind of forget about. I need to worry about. Now back in 305, you talked about these S, P, D, and F configurations. Theoretically, you did anyway. The only ones we usually care about are the valence configurations because that determines structure, just like Dr. Lewis talked about. Okay. Are any questions again about this core versus valence stuff? I'm going to break this down further for you, but this is how it's set up. Okay, so let's go back to yeah. Okay, so we have. Now, as far as this class is concerned in Lewis structures, this is all we have to worry about. We have hydrogen, boron, carbon, nitrogen, oxygen, and fluorine, and the periods associated with those. So the number of valence electrons for hydrogen is 1, for boron 3, 4, 5, 6, and 7. Oops. 7, not that. Right? Does everyone see where I got those numbers from? This would be period 1, period 3, period 4, period 5, period 6, period 7. Okay, so what does hydrogen look like as far as Lewis is concerned? It has 1 electron. So we're going to do it like that. Carbon's got 4. Nitrogen's 5. Now, there's a big difference with nitrogen now. Okay, notice it's got 3 singletons and a pair. The pair has to stay together. So there's 5 total. 2 in the pair, 3 singletons add up to 5. Oxygen's got 2 pair, 2 singletons, total is 6. Fluorine has 1 singleton and 3 pairs. Now, does everyone see where I got these dots from this here? Any questions about that?
Where do you get those dots?
Hydrogen said it has 1 valence electron, right there. Boron says it has 3 valence electrons. This is how they're set up, 3 singletons. Carbon has 4 valence electrons, and there are 4 singletons. Nitrogen's got 5, but because of quantum mechanics, this is the way it's set up. It has 2 of them are paired up together, and you have 3 singletons. Is that making more sense?
Yes.
Okay, so if you count these 2, 3, 4, 5, it's got to be the same as that. Now, know these.
Professor?
Yeah.
Somebody in the chat asked if we have to memorize the periodic table for the exams.
Absolutely not. Absolutely not. This is all I want you to know right now for the periodic table. These guys here, Lewis dot structures. Okay, so basically we're looking at period 1, period 2 on the periodic table. That's it, no more. Okay, are there any more questions about this? And please, let's see. I'm having to manually look at the chat here. It doesn't automatically show it to me. Tiffany, did that answer your question?
Yes, it did. Thank you.
Okay. So, okay. All right, know these. Okay. When I say know it, you're going to be practicing this a zillion, so you'll after a while, you have to memorize it because you've used it so much, you already know. Okay, so let's go back up here. To that. And we're going to be using these guys here to put that together. Now, this formula says there's one carbon, one is optional in the subscript, one carbon, 4 hydrogens. So step number 1 is you're going to be looking at all the atoms in the molecule. In the middle goes the one with the most singletons. So which has more singletons, carbon or hydrogen?
Carbon.
Carbon has 4, hydrogen has 1. So that goes in the middle. And I usually like to use different colors. And then the hydrogens, the ones that have singletons, the fluorine and the hydrogen go around the outside. Because the more singletons you have, the more combinations you can have. So we're going to put 4 hydrogens around that carbon. And I'm going to put them in close proximity to those singletons, because that's how they're going to bond. So step number 1 is put this is for singletons. Okay, so in the case of hydrogen, there's 1, carbon's got 4, so it's the most complex, so it goes in the middle. Step 2. Now there are 2 ways to do Lewis structures. There's one where you count all the valence electrons. This is a different approach, and I think most students I've found in past 14 years find this is a more approachable way to do it. Okay, so the next step is to connect all atoms with a pair of electrons. And usually what we do is we just take and circle them. Okay. Next thing we do is check for leftover singletons. Are there any leftover singletons?
No.
Good. Okay. We don't have to worry about them. If we had singletons left over, that's called a free radical. Free radicals are very, very, very unstable and immediately want to react. And that's why during nuclear poisoning, during a nuclear bomb, or a Chernobyl-like disaster, there was a lot of free radicals running around from that nuclear disaster, and a lot of people got radiation poisoning because of it. So free radicals are bad. That's why they should always be paired up. And I'm going to go over some examples where we have singletons left over. Okay, the next step is verify the number of bonds are correct. Now let's go back up here. Let's put in number of bonds. Okay, hydrogen needs 1 bond. Boron needs 3. Carbon needs 4. Nitrogen needs 3. Oxygen needs 2. Fluorine needs 1. Okay, that corresponds to the number of singletons. So hydrogen has 1 singleton, number of bonds is 1. Boron has 3 singletons, 3 bonds. Carbon's got 4 singletons, 4 bonds. Nitrogen has 3 singletons, 3 bonds. Oxygen's got 2 singletons, 2 bonds. Fluorine has 1 singleton, 1 bond. Okay, and you see where I get the number of bonds? Is that clear?
Can you explain where you got the number of bonds, please?
It has to do with the number of singletons. How many singletons does hydrogen have?
1,
1 bond. How many singletons does boron have?
3,
3 bonds. Carbon,
4.
4 bonds. Nitrogen,
Is it 5?
3. 3
Three.
singletons.
Singletons. Got
This is
it.
a pair. That's where oxygen over here. Oops, let me get rid of that. Oxygen has got 2 singletons, 2 bonds. Fluorine has 1 singleton, 1 bond.
Got it. Now I got it. Thank you.
Okay. Now, that's important because now we need to go down here. I'm going to verify the number of bonds are correct for each atom. And this is per atom. Okay, so let's go back up here now. How many bonds should carbon have?
One.
How many?
4.
4. Well, let's count. 1, 2, 3, 4. So carbon's good. How many bonds should hydrogen have? Each one.
1.
I'm sorry, what?
1.
1. This hydrogen has 1. Top one, the one on the left has 1. One on the bottom has 1. One on the right has 1. So we've met that criteria. Okay. Does everyone see how we validate the number of bonds? And the next we're going to do is we're going to validate the octets are correct for each atom, except for hydrogen. Okay. So how many total electrons are involved in the carbon bonding? Total now. We have 2 here.
8.
8, exactly. We have 2 here, 2 here, 2. There's 4 bonds. Each one has a pair of electrons in it. This is the math in the class. 4 times 2 is 8. Octet means 8. So carbon has its octet. Hydrogen only has two electrons total. So there's no way you can have 8. Hydrogen is 2 electrons. So we have hydrogen at 2. Everything else is at 8. So carbon's got 8. Each of the hydrogens are sharing 2 electrons. Now, when we circle these 2 electrons, we are sharing electrons. That's why we can count them for carbon, because they're being shared by carbon. So carbon's got 1 itself, and then shares the hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. So he's sharing a total of 8, 4 of its own, and 4 from the hydrogens. That's where the word covalent gets its name from. Co meaning share, valent, valence electrons. So what carbon and hydrogen are doing here is are sharing valence electrons. That's the predominant bond in organic chemistry and biochemistry is a covalent bond. Okay, so what's going on here? So we verify the octets are all correct. And then lastly, step 6 is to substitute a solid line for each bonding pair. So now we're going to rewrite this like this. That's the Lewis structure. Now, does that differ a lot from the way you did it in 305?
No, that's like how we did it in 305.
You did it very similarly in 305?
Yeah.
Oh, good. Good, good, good. Okay, I'm trying to manually look at the chats here, so every now and then I'll pause. Okay, so what if we have something other than carbon and hydrogen? Let's look at something like what chemical is that?
Carbon dioxide.
Carbon dioxide. Okay. Carbon dioxide. Okay. All right. So let's do the Lewis dot structure for carbon dioxide. Okay. Of the carbon and oxygen, which has more singletons?
Carbon.
Exactly. So carbon goes in the middle. And then what's left over are the oxygens. So we're just going to put them. Now, when you use Lewis dot structures, you can, don't forget, these molecules can rotate in free space. So we can put the oxygens in different places and still have a legal Lewis structure. So let's just put one here. Now, the pairs don't do the bonding. The singletons do. So we're going to put the pairs in the back of the oxygen. Okay, so that's step 1. Step 2 is we connect the singletons together. Once. Okay, the next step is, are there any singletons left unbonded?
Yes.
There are, huh? Remember, free radicals. We got to bond them up so they're more stable now. So we have one here and one here. Now, what I didn't do is connect the 2 singletons and the carbon itself. It is more stable to connect them to another molecule, another atom, rather than to itself. Excuse me. So if possible, we're going to bond it to another atom. Okay, so now do we have any singletons left over?
No.
Nope. So we're done. Okay. Next step is we verify the number of bonds. Okay, how many bonds does carbon need?
4.
4. 1, 2, 3, 4. So that's good. How many bonds for oxygen?
2.
2. Each oxygen has 2 bonds. So that's verified. Let's look at octets. Carbon's got, because we're doing covalent bonding and sharing electrons, carbon's got 2, 4, 6, 8. Oxygen's got 2, 4, 6, 8. We have to count the electron pairs when we count octets. So oxygen has got 8. The other oxygen also has 8. So that's verified. So that's a legal structure. We have to pretty it up by connecting the pairs with solid lines. So that's the Lewis structure for carbon dioxide.
So do these represent a bond?
Again?
Do the lines represent a bond?
Yeah, exactly. Perfect. Yes, exactly. So carbon oxygen here is a double bond.
Professor, could
Bingo.
you do an example of boron since it only has 6 of valence electrons?
Borons is we're not going to. Boron is an exception because it only has 6 total. So when you do boron, there's some tricky stuff that we're not going to get into in this class. So don't worry about boron. It has to do with there's some empty orbitals available that can be used. We're not going to do boron. Lewis covers boron, but we're not going to do boron in this class. Remember we talked about carbon, hydrogen, oxygen, nitrogen, sulfur. Okay? But boron does have 3 valence electrons. Was that your question to do one with boron?
Yeah.
Yeah, so let's not do one with boron. Let's do one more. Let's see what time is it? 1:30. Yeah, let's do one more Lewis structure. Let's do by the way, there can be multiple legal Lewis structures. Okay, so let's do a Lewis structure for C2H6O. Does anyone know what that chemical is called? Well, an adult beverage called ethanol. Or drinking alcohol. However, there are 2 legal Lewis structures for this. One of them is called ethanol, the other one is called dimethyl ether. And we're going to be getting into these when we get into the alcohol chapter. So let's do a Lewis structure for these. Now there's going to be 2 legal structures. Yeah, Maria, that's right on the control. Good. Okay, so let's do this. Okay, so we have carbon, hydrogen, oxygen. Which is the most complex as far as singletons go?
Carbon.
Carbon. Okay, the next one is going to be oxygen. We can stick it anywhere. Let's just stick it on the right. And then we have the 6 hydrogens. Okay, that's step 1. Step 2 is connect them up with 1 bond per atom to start with. In fact, let's use a different color. And this is ugly over here on the right. How can we fix that? That
Move the hydrogen lower, like towards the other singleton on oxygen.
Yes, but what's how can we fix the layout?
Try rearranging, so like put 2 on top and 2 on bottom, and then move one of the singletons to the side.
Yeah, just move these around. As long as we have 2 singletons and 2 pairs, we're fine. It does not matter how you move them around. So for our convenience, we're gonna move it around so the singletons are close to one another. That's what you're saying, right? I think something like that. Yeah, so put them on the top and bottom. It's okay. Now we have everything's connected up with one bond. Now, do we have any lone singletons?
No.
No lone singletons. We're done. Okay. Next thing is we have to verify this is a legal Lewis structure. So carbon needs 8 atoms, or excuse me, 8 electrons for the octet. So we have 2, 4, 6, 8, and it's got 4 bonds. That's good. This carbon's the same thing. Oxygen needs 2, 4, 6, 8 octet. It needs 2 bonds. The hydrogens all need 1 bond and 2 electrons, and they all have that. So this is legal. Does everyone see why it's legal? Are there any questions about that?
No.
And then the last step is going to connect it up with lines. You have that. So that's structure number 1. That is what ethanol looks like. Now, when we start naming organic compounds, an OL ending corresponds to alcohols, and that's what this is, alcohol. Now, there's isopropanol, rubbing alcohol, there's propanol, there's butanol, there's methanol, all kinds of alcohols, including carbohydrates. So in nature, there's a whole bunch of different kinds of alcohols. The one most people are familiar with is isopropanol, rubbing alcohol, and ethanol. But there's zillions of alcohols out there. Okay, so that's the first legal structure. Let's do another legal structure for that formula. So instead of putting the carbons in the middle, we're going to put the carbons and the oxygen in the middle instead. Okay, so we've got 6 hydrogens, 2 carbons, 1 oxygen. Step number 1, connect them all with single bonds. Okay. No lone singletons. So we need to verify this is a legal structure. Carbon needs 4 bonds, 1, 2, 3, 4. One on the right's got 4 as well. Oxygen needs 2 bonds. Excuse me. Left and right for the oxygen's got 2 bonds. Octets, oxygen has 2, 4, 6, 8. 2 are paired. And you have 2 bonds at 2 apiece, so that's 8 total. Hydrogen needs 2, 2 and 2. Hydrogen needs 2, 2 and 2. So this is legal. So this is structure number 2. What does it look like? So that's the dimethyl ether. Both are valid structures. Now the problem is, which is correct? As a chemist, you go, well, I don't know which is correct. So now we have to take and do some more reactions to see if this formula, C2H6O, acts more like an alcohol, or does it act more like an ether? If it acts more like an alcohol, well, then ethanol is the correct structure. If it acts chemically more like an ether, then ether is the correct structure for our C2H6. Okay, so bottom line is you can have multiple legal Lewis structures. So I mean, sometimes you can have like 6 or 8. Now in a test, I might say draw a little structure for that, and either one would be correct. Either one. Unless I said draw 2 legal structures, then you have to draw both of them. Okay, so how are you guys doing with this? No, I'm looking at your chat questions. So I didn't even have to look at it, I already answered. Okay, so for dry lab number 1, you're gonna be doing a lot of this. Now on Wednesday, I want to talk about, excuse me, I want to talk about rewriting some of these structures. For example, instead of writing all these hydrogens and all these carbons, we're going to make a shorthand way of writing this structure. And as a harbinger of what's to come, this is what this structure is going to look like. Once we write, this is called a line form. I'm going to go from this to that. And I'll show you how to do that. So one is a lot quicker. If you look at biochemists, they never write hydrogens. For example, this is what glucose looks like. The only time they write a hydrogen is when it's connected to the oxygen. So we have carbon, 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 and there's oxygen in here without double checking. So biochemist, this is glucose. Okay. You'll be knowing that relatively soon. So organic chemists and biochemists rarely write C's and almost never write H's. Okay, I just got a message from someone saying they dropped the class accidentally. I need to get back on the rails. Okay, all right. Okay, so I'm going to end it here. I want to cover any questions that. Now this is in chapter 4 in your book. So if you need practice, are there any questions about what we've done here in this OneNote before I close this?
Professor?
Yeah.
So I would just like to verify for the example that we just finished. So carbon has 4 number of bonds, right?
Right.
And hydrogen has 1, and then oxygen has 2, correct?
Correct.
But how does that, where's, okay, so hydrogen has 1, but 1, 2, 3, 4, 5, 6, 7. For some reason, I'm counting, I think, the pairs and counting them as bonds.
Correct. Don't. Because the only time you have a bond is if you have singletons. Oxygen only has 2 singletons, hence 2 bonds.
Gotcha. Okay, thank you.
Nitrogen has how many singletons?
Singletons for nitrogen. Give me 1 second. 3 singletons.
Yeah. So how many bonds?
2. I'm sorry.
1 per singleton. So how many does nitrogen have?
Nitrogen has 3 singletons and 3 number of bonds.
Yeah, exactly.
Okay.
Yeah, number of singletons equals number of bonds.
Thank you.
Hydrogen has 1 singleton, so guess what? 1 bond. Fluorine has 1 singleton, guess what? 1 bond. Now you can total up, let's go back up here to carbon dioxide. Now, how many bonds does carbon have in the middle?
How many bonds carbon? It has 4 in that one.
Yeah.
Or in
But we have 2 doubles. So the 2 doubles are 2.
Those equate to 4, right?
Yeah. exactly.
Okay, thank you, Professor.
That makes sense now?
Yes, it does. Thank you.
Cool. Any other questions?
Are we automatically marked present when we log into Zoom?
Yes, I can get an attendance by going to Zoom, so you don't have to worry about present. That way, in case someone forgets to do that, Zoom has a record of everyone on this, on here. That's how I get attendance. Did that answer your question?
Yes.
Okay. So roll call will automatically be done by Canvas. Thank you, Canvas. I mean, Zoom. I mean. Thank you, Zoom. Okay, so I'm going to stop sharing this. One last time, any questions on this? Now, this is important to practice. I'm going to show you in a minute how you can practice this. So how do you practice Lewis structures more? If you go to, where's Canvas? What happened to Canvas? I lost my Canvas. That's not it. Where is Canvas on here? I had it up before. Do you guys see this?
Yes.
Okay. Why did it come up before? Okay. All right. So if we're starting at home screen. Okay, if you want more practice on Lewis dot structures, you go to Files, go down to Unit 1, and there's a whole bunch of worksheets here. You want to practice in Lewis dot structures with answers, I might add. Now, what I'd like you to do in the next, for Wednesday or for Monday, I'm not sure whether I'm going to get to this or not, print this out. These are our reactions for Unit 1. And we're going to be going through all these in subsequent lectures, but it's nice if you have a printout of this so you can follow along with me. Our first reactions are going to be with alkanes, that's chapter 12. And alkanes can, via spark, go to combustion, via an addition reaction with Cl2 form a haloalkane. And that would be chapter 12. This is chapter 13 down here. And basically, this is what test 1 will cover, these guys. But if you print it off, it's really nice when you can follow along. And we have unit 2 reactions, which add to this, unit 3 reactions, etc. This is where the memorization comes in, by the way. And I'm going to give you this on the test, by the way. The problem is you need to know how to use this. And we're going to be using this every single lecture. So it should become more obvious as the more we use it. Okay, but print it off. And for those of you who don't have a printer, you should be able to find a place like over at Mesa, or various student organizations that allow you resources. And can you print at the library?
Yes, I think it's like 10 cents per paper page you print.
Oh, 10 cents a page. That's wrong. Well, if you look at some of these organizations, they will have printing services available for you. Or if you email me, I can print one out for you at home and bring it to you. Either way. I just want you to have it though, print it. Okay. Are there any further questions? Okay, all right. So typically we end about 10 till to give everyone a chance, adequate time to get over to the lab. So I will see you in a little over an hour. Okay? Good talking with you guys. And this is going to be a video too, by the way. Every lecture, assuming you guys remind me. There are assignments in lab I'm going to talk about. Okay, so I'm going to end this, and I will see you for Monday, folks. I'll see you in lab in a little while. For everyone else, I'll see you Wednesday at noon for Zoom, unless you need an office Zoom. Just let me know.